Uh, the topic of my thesis was IDS in Open BIM Workflow, Potential and Limitations, a work which was conducted under the academic supervision of José Granja and Miguel Azaña of the University Minho. And I had a company supervisor, Luigi Alfaro of the company Dirits. So we all know that BIM integrates graphical, 3D, and non-graphical, also called alphanumeric data. And alphanumeric data is the topic of this thesis, as IDS is precisely what this addresses. What I have here for you is a very famous graph by now, as I am sure, and it is IDS and Open BIM Workflow provided by Building Smart International. The process starts with client, who creates an IDS file and thus defines all the alphanumeric information. This IDS file is then sent to the modeler, who verifies if he or she can pull it off. And then they proceed to model the data. Right before the final IFC file is exported and sent to the client, there is the option to validate the model against IDS and thus capture any issues which are communicated through BCFs. Now, there are already on the market many tools which address the very first and the very last step of this workflow, sort of IDS checkers and IDS creators. However, the rest of this workflow is omitted, which presents from academic standpoint a gap, and from a business standpoint an opportunity. So the word information delivery specification, or IDS, was uttered. So let's have a look at that. It is a Building Smart standard approved on June 4th, 2024, so very new. It addresses the need to specify alphanumeric and textual information requirements. It is XML-based, which means it's easily interpretable by computers and readable by humans. It is open source, so it's free of charge and free to use. It covers 3 IFC versions. And what I have here for you is a specific, or let's say typical IDS specification. So in figure 2, we see the specification in plain text, the more human readable part. So we have there, the model must contain entities that have IFC class, IFC column with a predefined type stand column. And what I have in figure 3 is the very same thing, just written in XML format. So the more computer interpretable format. The term specification was uttered. So let's have a look at that. A specification consists of 3 components. We have description, which is more for humans to read and to clarify the purpose. Why are we setting this specification? Then we have applicability, where we define a subset of IFC for which this specification is valid. We use for these 6 facets, but more on this in the next slide. And then we have requirement, where we set the requirement for the subset identified, sort of value restrictions. These specifications, of course, come with 3 degrees of cardinality. Firstly, we have must, which is obligatory. We have to include it in the model. Then we have may, optional. We may or may not include this in the model. And lastly, we have must not, or prohibited. We cannot include it in the model. Let's look at facets. You can sort of think of it as filters. With these, you can filter the data in IFC. So firstly, we have entity, such as IFC column with predefined type, stand column, then attribute, which is an entity-specific property. For example, here, overall height. Then we have classification, where we can define system, value, and URI. Then very handy facet property, where we define property set, base name, which is the name of the property, data type, value, and once again, URI. Then material, and lastly, part of, which is more of a niche facet. It defines basically relation between 2 IFC entities. Now, how to restrict the values? Well, we have two possibilities. We have type constraining. So we can say that this value has to be of IFC Boolean, IFC label, IFC tag, or IFC length measure type. And then we have complex restrictions, where we use regular expressions for more specific patterns. So I have here enumeration, where we can select from a list. Then I have a pattern, which you can imagine on a task you are about to name pipe segments. This would be a requirement which you would set there. Then we have bounds from which value until which value. And lastly, length. So this was value constraining. Now let's have a look how Revit handles IFC and by extension IDS. IFC exporter for Revit is certified by Building Smart International. It is embedded into Revit. It is written in C# and uses three particular files for mapping. We have Revit IFC building, where we have all the property sets, quantity sets, attributes, predefined types, and so on. This one is non-editable. However, we can import it into Revit as shared parameter file. Then we have IFC 4x3, or it might be a different file depending on the IFC version which you use, which contains all the certified IFC entities and enumerations. This one is also non-editable. And then we have lastly mapping parameters text file, where we can map our rated data to custom property sets and properties in IFC. This one, of course, is editable. Now let's look at Revit's compatibility with facets. So entity, there is no problem. We can define name and predefined types from the IFC 4x3 file. Attributes, also not a problem if we can find it in the Revit IFC built-in, because if we cannot, you will have a very hard time to define such an attribute. Classification, also compliant for system and value. With URE, that is a problem because with a standalone version, there is no way how to put UREs into your Revit model. Property set, also very well done. Properties that you can define the properties, data type, values. Only URI is problem. Material, also not an issue apart from the URI. However, part of, if you just think about it, part of qualifies two relationships in IFC entities, between IFC entities. And you have to do this inside Revit. Well, it's very complicated. So that is why it's here marked as non-compliant. Now, to show you the intricacies, how to work with facets inside Revit, I have here an example for the attribute asset. So we have two ways how to have attributes in Revit models. First is to identify all the hard-coded attributes, which Revit automatically assigns to IFC attributes. So what I have here is the parameter project status, and project status will always be exported to IFC project phase attribute no matter what. There's no way how to change it. It is hard-coded. And then we have the shared parameter file from the Revit IFC built-in. So I populated my Revit model with the parameter IFC site.guid, and this parameter, Revit parameter, got exported into IFC as GUID attribute of the entity IFC site. So this is user defined. Now let's have a look at properties. So or value constraining. If we have a data type prescribed in IDS, which you have to use, and if this data type comes from a predefined property set, quantity set, or attribute, well, generally there is not an issue. And if this property set is found in Revit IFC built-in, the proper data type will get exported. However, if we have user-defined property sets and properties, we have to use the mapping parameter text file, and Revit allows us to use only 34 data types, but this is just for the user-defined. Now, You are probably thinking that all of this is very complex and hard to comprehend, and that is the correct assumption. It is an interoperability issue. So what I have here is the same workflow graph, which I showed you before, however, split into two segments. We have IDS and open the workflow inside modeling software and outside modeling software. Outside modeling software, you don't have two systems to adhere to, you have just the IFC, so it is easier to master. However, inside modeling software, this is the part which gets omitted. So it was decided that I should create an IDS verification tool for Revit. So the step in the workflow marked in red. So it is a C# application which utilizes Revit ISC capabilities and IDS. And to validate if each specification is compliant with Revit, basically if you would be able to pull it off in Revit, that is very hard to do. So it was decided to split each specification to facets and data types, then validate each and every facet and data type individually. And if they as a whole are compliant with Revit, then it is considered that the whole specification is compatible with Revit. This is done with a special C# class called IDS data store, which extracts data from IDS file and breaks it down into facets, for example, the facet entity, and then proceeds even more and breaks it down into individual entities, enumerations, and cardinality. There are three key C# classes. We have IDS data store, which handles the IDS file. Then we have IFC TXT loader, which handles all the B sets, quantity sets, and attributes. And then we have IFC XSD loader, which handles all the entities and enumerations. And the logic is as follows. Here we have once again the example for entity. It first checks the cardinality. If the cardinality is set to must not or may, then we don't have to include this entity in the model. So it is technically compliant. We don't have to do it. If the cardinality is, however, set to must, then we have to do it. So it goes a step further. It checks whether the entities and enumerations can be found in the IFC XSD loader. If they are found, then yes, we can model this in Revit and it is compliant. If no, then it is considered non-compliant. And what I have here is a preview of the application. So it starts with the modeler uploading the IDS file. It gives you an instant feedback. Then you have the option to preview the data, the raw IDS file. Then this is what happens when you click on the tab entities. So it highlights all the non-compliant entities. And this is what happens if you click on data types. Actually, I have the app loaded here. Can you just confirm that you can see the IDS checker? Can you see the app?
Yes, we can see.
Okay. So when I upload an IDS file, you can see it tracks the data. This is what happens when I click on the preview tab. Then if I click on facets, this is how it extracts all the entities, attributes. So here are not that many attributes, classification, properties, material, part of. You see this was a relatively empty IDS file, and data types. Okay. So I think that concludes my presentation.